So welcome to the video. Today we are going to take a look at how to do a Wilcoxon signed ranked test on version 31 of SPSS. So we're going to use this test when we have an independent categorical variable comprised of two levels. So that's a within subjects or within participants categorical variable, and when we have an ordinal or continuous dependent variable. So for this example, we are going to imagine that we're looking at people's depression scores before and after a CBT intervention. So in this column here, we have depression scores before the intervention, and in this column here we have depression scores after the intervention. So let's take a look at how to put these data into SPSS. So we can go down to data view, and then let's just give a name to the first level of this independent variable. So let's call this something like before, and then in the row below we can give a name to the other level of the independent variable. So let's call it after, and in this case we have scale data, so we're going to just use this measures column here to indicate that we have scale data. And then we'll go down to data view, and we can see that before and after appear at the top of these two columns. So then we can go back to this Excel file, and I'm just going to select all of these data. Then I'll go to Command or Control C to copy those data. Then I'll go to the top left cell in SPSS, and then I'll go to Command or Control V to paste those data into these two columns. Sometimes that won't work, in which case you can just go up to Edit and then down to Paste, and that usually does the trick. So now that we've got the data in SPSS, we're ready to run the analysis. So we can go up to Analyze, and then down to Non-Parametric Tests, and then over to Legacy Dialogues, and then down to Two Related Samples. We can see here that we have Wilcoxon ticked already, so we can just select both levels of our independent variable and move them over to these two spaces using this arrow. I'll also go to options and I'll tick quartiles because that will provide us with median values in the output. So then let's go to continue and then to OK. So that runs the analysis for us. I'll just show you how to create a graph as well. So let's go up to graphs and then down to chart builder. If this comes up, you can just ignore it by going to OK. I'm then going to double click on this option here, this simple bar chart option, which makes it appear up here. I can then transfer before to the y-axis as well as after. That will open this window here, which you can just close by going to OK. Something to bear in mind is that this process of dragging the variables into this y-axis box won't work if you have your variables set to ordinal. So if we go to data view again, if you have your variables set to ordinal like this process that I just described won't work. So even if you do have ordinal data, which is an option with the Wilcoxon test, I would set it to scale if you want to create a graph. So once we've got these variables here, I'm just going to go to this menu here and indicate that we want our bars to represent medians rather than means, as it's more common to use medians when we're doing non-parametric tests that compare scores between conditions or between time points. So once this looks like this, we can go down to OK, and we can see that that creates this graph for us. If we want to edit it, we can just double click on it to open the chart editor, and if we double click on any bars, we can open this properties menu. We can use this bar options tab to change the width of those bars, and if we go left, we can find this fill and border tab, and we can use this to change the color of the bars. We can also click on any text within the graph to change the font style, for example, or to change the font size, and any changes that we make here will be saved automatically. So we can just go to this red button when we're ready, and those changes will appear in the output file. So let's take a quick look now at how to interpret the results of the test. So the first thing I'm going to look at is this descriptive statistics table, and we can see that we have a median value of 22 before and a median value of 15 after. So it looks like the CBT intervention led to a decrease in depression scores, and we can use this test statistics table to determine whether that difference is significant. So if we look at this asymp_sig two-tailed row, we can see that we have a p or sig value of less than 0.001, and as this is less than 0.05, it indicates that there was a significant difference in depression between those two time points. So let's take a look now at how to write up these results. So I have an example here, and I've said that a Wilcoxon signed ranked test revealed that depression scores were significantly lower after CBT compared to before, and I've referred to those medians that we looked at previously. So we had a median of 15 after and a median of 22 before. Just to remind you of where those come from. Those come from this descriptive statistics table and this median column, where we have a median of 22 for before and a median of 15 for after. We also have these n values in this table. So we had 15 participants in the study before the intervention, and we had 15 participants in the study after the intervention, and that has been reported here and here. Next we have the Z value of negative 3.87, and that's coming from this test statistics table, and the Z row where we have this value here of negative 3.873, which we've just rounded to 2 decimal places. And as we saw before, we have this P or sig value of less than 0.001, and that's what I've reported here. So lastly, we have this R value, which is an effect size statistic. Unfortunately, SPSS doesn't actually provide this for us, so we have to calculate it ourselves. And to do this, we take the Z value and we divide that by the square root of the total number of observations. And when we're looking at the Z value, we can ignore any minus symbol that might be in front of it. So the total number of observations is basically 15 from after the intervention and 15 from before the intervention. So we had 30 observations in total. And the easiest way to calculate this value is just to put those numbers into Google. So here we have 3.87, so that's the Z value. And I've just divided that by the square root of 30, so the total number of observations. And that has provided me with this value here of 0.71 if we round it to 2 decimal places, and that's what we've reported here. And so I've described that as large based on these criteria that Cohen put forward in 1988. So he said that an R value above 0.1 can be described as small, an R value above 0.3 can be described as moderate, and an R value above 0.5 can be described as large, and as 0.71 is bigger than 0.5, I've described that as a large effect size. So that's about it for the Wilcoxon signed ranked test on version 31 of SPSS. I hope that was helpful. If you have any questions, just let me know in the comments and I will try to get back to you. Thank you very much for watching, and I'll see you next time.